So good morning, Kiran sir. సార్ మీరు మ్యూట్ లో కనిపిస్తుంది సార్, మీరు అన్మ్యూట్ చేసుకోండి సార్.
గుడ్ మార్నింగ్ సార్. గుడ్ మార్నింగ్. ఏమన్నా అడుగులు సార్?
ఎస్ సార్, క్లియర్ సార్.
ఓకే సార్.
Shall we start, sir? Kiran sir?
Yes, sir. Please, sir.
Right, sir. Jaya, please take over the proceedings.
Good morning to everyone. I welcome you all to the day 5 forenoon session of 1 week online FTP on recent trends in intelligent systems, sponsored by AICTE-ISTE and organizing by Department of ECE, Vardhaman College of Engineering. Today, the session of the FTP will focus on the topic of ambient intelligent systems in smart cities. Now, it's a moment of extreme pleasure to introduce today's speaker, Dr. G. Kiran Kumar sir. Dr. G. Kiran Kumar sir has been working as HOD and assistant professor in the Department of ECE, NIT, Andhra Pradesh since 2018. Dr. G. Kiran Kumar sir has completed his bachelor degree in electronics and communication engineering, MTech in telematics and signal processing from NIT Roorkela in 2011, and PhD in wireless communications from NIT Roorkela in 2017. To his credit, he has published 26 research articles to date, which includes 9 SCI journals and 16 conferences. In addition, he has guided 1 PG project and 80 UG projects. He is an active reviewer of various reputed journals like Journal of Communication Systems, Wireless Personal Communications, IEEE Access, International Journal of Electronics. His research interest includes cooperative communications in wireless networks, 5G, and physical layer security and resource allocation. Once again, I welcome Dr. G. Kiran Kumar sir. Please start the session.
Thank you very much. Good morning, all. So today we discuss about ambient intelligent systems in smart radio environments. As a part of that, we will start with the basic idea behind this ambient intelligent system. What is the need of this in current smart radio environment? The combination of these two, how this combination will address the basic needs of current society. So these things we will see, and in our discussion we take an example of one ambient intelligence based system. So those who are interested in this particular area, they can continue their research with this particular example, and those who want to do some modifications to this, they can add some changes. And we can discuss here the future research challenges also regarding this particular topic. What are the possibilities we have to implement a particular example of ambient intelligence system in smart radio environment. So we discuss these things in our presentation. So I'm sharing this. Is it visible?
Yes, sir. 8K.
Yes, sir. Thank you. Whiteboard only.
Yes,
In
sir.
today's discussion, we see the first title and outline of my presentation, and we'll come to again back to this slide of whiteboard. We'll explain the things. So coming to the outline of my presentation, today we are going to discuss ambient intelligence systems in smart cities or smart read environments, whatever may be the thing. So this is the outline of my presentation. So coming to the fifth point. So this is an example of ambient intelligence based system for a smart radio application. As an example, we consider this artificial intelligence assisted Swift enabled cooperative normal based IoT network. So first we see what is the basic principle behind the ambient intelligence system and what are the basic operations required to propose an ambient intelligence system and how it will be if you apply for a smart radio environment. As a part of this, we are preparing a system example which includes the cooperative wireless network, NOMA, Swift, the combination of these three for an IoT domain. This will address any kind of smart radio environment, example, smart healthcare, smart disaster management, smart remote healthcare, smart remote based communication, you can do it, and smart satellite communication, smart intra-terrestrial communication, smart vehicular-to-vehicular communication, smart device-to-device communication. So anything is possible. In smart radio environment, we can apply these combinations. We can apply it as a system model. So before going to this outline and all, one by one, so first we see what is an ambient intelligence system, the basic principle of this particular system, and how it will be to apply for a smart radio environment. These questions we need to address now. Then we'll come back to our system model again. So as a first part of our discussion, so we need to define what is an ambient intelligence system. A simple real-time example for this, it may be anything as much as simple as cyber physical system. A simple cyber physical system. A simple machinery is there. It is operating by its own. It's running. Let us assume it is a simple machinery. So we need to test its working capability. So we need to monitor what is the working capability of this machine. Is it in good working condition mode or is it facing any problems while it during running condition and all. So know the status of proper working condition of a machine. So for this, we are operating a machine. So we can keep some sensors, set up sensors near to this machine. So I used to keep some sensors. So it may be any kind of sensor. You can call these sensors as a smart sensors. Actual sensing capability of a sensor, along with that, some smartness. What's the meaning of smartness? The ability to monitor, ability to analyze, ability to take decision. If any sensor having these three capabilities, ability of sensing something, ability of analyzing something, ability of taking some decision based on the information we have, then we can call it as a smart sensor, a smart sensor. So we can keep some set of smart sensors near to a machine which is in running mode. Every time we used to monitor from these set of sensors, so we can collect some information. We get some information from these sensors. I think it is a raw data, one kind of raw data, because the sensors they collect some information from machinery and raw data, which is collaborated and get into a form of information. And we need to convert this amount of information collected from all sensors to a deterministic form of information, as simple as convert any form of energy into a particular another form of energy, which is done by transducer circuit, one form to another form conversion. So sensors collecting information, so it's a raw data. So convert this information into a binary information, so using a codec. So we are just converting the form of energy to binary information. So this is the data now, the information set we have. Do some processing over this information. We are doing some processing. What kind of processing we can do? Improper data to proper data. A raw kind of information to deterministic information. So that signal processing operations we perform. So what kind of signal operations we can do? So the next is collection of information is the first step. And as a second step, we need to process the information. We need to process the information, signal processing. Signal processing. What kind of signal processing we can do? So is there any noise analysis along with the signal? Because it's a sensor, it is more sensitive. So we have some kind of errors, absolute error, some tolerance while you are taking the measurement and all. So what kind of errors we have, we need to analyze. What kind of noise we have, we need to analyze. So some kind of noise minimization techniques we can apply. So if the signal is very weak from sensor because they are limited in energy, so the sensor information is very weak, sensitive, and with the low, can call simply low energy signals. We can boost, we can amplify the signal. That is one kind of processing. We can scale the amplitude of the signal. That is one kind of processing. We can minimize the impact of noise. That is one kind of processing. And is there any high levels? Reduce the levels. If any low levels, push the levels. So that is one form of scaling of a signal. This all comes under signal processing only. We do some signal processing operations over this information. This improper information now become as proper information. Now we have information. So we need decision making capability here. So there is an observer, an automatic observer. This is called intelligence. So based on the information, whatever we have, based on the information, we should have capability to take particular decision, whether the machine in working condition or not, proper working condition or not. So from the sensors, we collected information, we processed that information. Now we are in a position to analyze this information. So it is a data analysis. Simply data analysis means already we have prepared data sets. In data sets, whether the machine is working in proper working condition, the parameters are like this. If the machinery is not in good condition, the parameters are some other kind of parameters. So the values are different. The values are different. So based on the data we have for different possibilities of machinery. So throughout its operation of a machine, so we need to have data set for the machinery for all possibilities of working conditions. If it is good working condition, very bad working condition, it is with the limited amount of errors or limited number of problems it is facing. So all kinds of possibilities of machine working conditions to be saved as data set. And whatever the information we have received after signal processing applications of information, compare this with the data set we have prepared and know the condition of machinery, So here machine learning algorithms, which can give you the artificial intelligence to the system. So analysis and a decision making capability. These two things we can call it as simply artificial intelligence. We are adding some intelligence to the system. We are adding some smartness to the system. In simple meaning of these two, the possibility of analyzing something, the possibility of taking a decision over analyzed data. So both the things will happen here, analysis and decision making capability. Decision making capability. Now, so I tested it, I compared the information with the data set. I come to know the machinery is not working properly. There is some problem with this. There is some problem with this. So I come to know this. So what I can do? So I can activate some actuators. In between, actuators are there. So they perform some operations over this machinery to work it properly. So we are giving feedback via an actuator to machinery, to the machinery. So it can control the working condition of machinery. It can control the working condition of machinery such that every time we need to do all these things. Every time collect information from sensors, convert into proper form, do some signal processing applications, apply to artificial intelligence based system. So which has the capability of analysis and decision making capability, and give this information to actuator. This actuator will control the machinery. It's a loop. It's every time a loop. So which is called cyber physical system, automatic. There's no need of a particular human being present there to control this machine. This machine automatically will run, and if any problem with the machine, that automatically will be monitored, will be controlled, will be rectified by this actuator circuit with the help of artificial intelligence system. So this kind of example is nothing but ambient intelligence system. Ambient intelligence system. So within the system itself, it has the capability. Any real-time environment, it may be a smart room, a smart healthcare. What kind of smart communication system we can take an example. Within that, we have to include this ambient intelligence system. The meaning of this, within that, we need to have one embedded system, a microprocessor system, which will sense information from particular transmitter. It will collect that information, convert it to proper form of information. We do some signal processing applications. We give this example or this received information, which we converted into proper information form with the help of signal processing operations. That will be inputted to artificial intelligence system. So that will take some decision. According to the decision, we can activate our actuators to perform some controlling operations over the transmitter. So this is a loop again. It will control, monitor, it will perform some operations without the presence of a human being. So this comes under an ambient intelligence system. An ambient intelligence system. So we can interact between device to device. We can make an interaction between vehicle and vehicle. We can make interaction between a machine and a human being. A machine and a human being. Assume that even though it is a machine, even though it is not human, we are adding some smartness to the machine, and it has the ability to communicate with a human being. So now the best possibility, if next generation networks comes into picture, what will happen? A human being will able to communicate with a device, with a vehicle, with any kind of transmitter or receiver circuit. He can communicate with an electronic circuit. That is possible. A communication between a human and between an electronic device is possible with the capability of artificial intelligence, which is nothing but analysis and decision making capability. So that's the main advantage we have with this ambient intelligence system. If we have a simple block diagram, basic principle behind this, any real-time environment. Let us take an example of a smart room. Smart room. I need to automatically test the temperature and the pressure within that room, and we have to actuate without a need of a human being within the room. Remotely, we can operate something electronic goods within a particular room. We can able to monitor them. We can able to control them. So these things, if you perform without a physical presence of a human being inside the room, from outside itself. So that is an example of ambient intelligence system. So how it is possible? So inside the room, we can keep sensors. we can able to monitor the room. Based on the information collected by the sensors, we can take some decision. We do some controlling operations. So this particular loop will gives you an ambient intelligence system. So that may be a smart radio environment now. If you include a sensors, a particular transmitter with an IoT device, if you connect Internet of Things with all these devices, so you can make it as a remote. So now it becomes as much more easiest way to solve a smart radio environment problems. So simple block diagram consists of this ambient intelligent system is there, environment is there. So from this environment, every time I need to sense some information. Sensors, I should keep sensors and collect information from environment. And the collected information first converted into proper form of information. Then we do some signal processing operations. Then we apply to intelligence system that will take decisions based on the analysis. So in between a human being is there. He is controlling this environment. For that, we need to monitor this environment with the help of sensors, with the analysis capability and a decision-making capability we have with the ambient intelligence system. So it can make a proper interaction, intelligent interaction between human and environment. So this interaction is possible. So this complete loop, a physical loop, where we have a possibility to monitor the environment, there is a possibility to control this environment with the help of this ambient intelligence system. This is the basic principle behind an ambient intelligence system. So what are the possibilities we have if you write in simple block diagram format? So whatever the kind of smart radio environment you have, if you want to monitor this, so consider it as a smart radio environment. So this is the case I have to monitor, I have to control. So for this, we apply sensors. So using sensors, collect information. So the form of information you convert into proper form. So proper form of information. This information, we do some signal processing applications. And next, we'll give it to some machine learning algorithms or artificial intelligence based circuit. What it can do, first of all, it will analyze the data, whatever we have. So compare with the data set available, and it will take some decision making. So decision about nature of this smart radio environment, how this is smart radio environment currently. Based on that, we can take some decision. So it is decision making. From the decision making, we can activate some controlling functions with the help of an actuator. So these are actuators. So these will control the smart radio environment again. So this is a complete closed loop. This is an example of ambient intelligence system. So this is the basic principle behind this ambient intelligence system. Now the question is, what is the need of this artificial intelligence in smart radio environment? I'm saying it is a smart radio environment. Actual radio environment, we need to communicate information from source to destination. Now, what the smart radio will do, whether the transmission is a successful one or failure one, based on the reliability of the transmission, based on the quality of transformation we are doing from transmitter to receiver, there is a chance to enhance the performance. A simple example, So take an example of any radio communication system, simple communication system. So it's a transmitter and receiver. I have to transfer information from transmitter to receiver via a channel, through a channel. So let us assume X is the information I have to transfer from transmitter. So through this channel, after reaching the destination, let us assume the signal becomes as Y. The signal becomes as Y. So the mathematical representation of any communication system, we can write it as Y is equals to, actually the received signal should be equal to the transmitted signal. Y should be equal to X. But in between it is passing through the channel. Surely there is an impact of channel on the information signal. So the impact, let us assume the channel impact is H. In time domain it is convolution of H with X. If it is time dependent, if it is independent of time, we can write convolution as multiplication. So Y is equal to Hx plus, and it is N. I'm writing it as plus N. So it is noise. There is no guarantee that always noise politely will come and add it to the information signal. But among all possibilities of noise impacts, minimum impact is addition. That's why I'm writing it as plus N. This kind of noise is ideal in nature. That's why you can also say AWGN noise. AWGN noise. This is a representation of any simple communication system. The received signal at the destination or at the receiver is equals to original information signal to be transmitted in convolution with the impulse response of channel. We can visualize this channel as a dielectric medium with respect to electromagnetic waves. With respect to signal processing, we can call it as an LTA system or time variant system. So with respect to a plot fading, we can call it as a simple multiplication of channel impact with the information signal X plus N. I'm writing it as plus N. Ideally, it is plus N. It is an assumption only. In real time, it is not possible because noise generally random in nature. We don't know how it can impact our signal. So noise can be scaled, noise can be added, noise can be convoluted, noise can disturb our signal in any format at any level. So there is no guarantee always that noise can be added plus N. So that's why it is additive. Why you are taking additive? Because it is ideal minimal noise. So among all possibilities of noise impacts, minimum possibility is addition. That's why I'm taking it as additive. White because it is an high power spectral density is constant. There's a specialty of white color, which are where other colors don't have this particular kind of thing. Because coming to other colors, we have variations like blue, light blue, sky blue, thick blue. But white, wherever it is white, we can call it a white only. So Gaussian, I'm saying noise is random in nature. That's why. So we should distribute it because instant values should not represent noise. So noise is a random signal. So random signals cannot be determined with a single instant values. Instead of that, we have to take distributions. Among all distributions we have for random, ideal is the Gaussian. If you combine all the ideal qualities of noise, you can call it as AWGN noise. Now coming to ambient technology, so we need to have Y is equal to X. So that means we need to minimize the impact of noise and we have to remove the impact of channel. So we have equalizers, so we can remove this. There is no circuitry available to make noise completely zero. But what we can able to do, we can able to minimize the impact of noise. That possibility is there. That is assume we minimized the impact of noise. So it may be approximately equal to Hx. So multiply with the inverse filter. Hh get cancelled out, it is approximately equal to X. So this 1 over H is called inverse filter or equalizer. So you want to improve the quality of your transmission. So surely we need to take some precautions, some causing effects regarding this channel and the noise. We have two limiting factors here. One is channel, another one is noise. So the analysis of these two, suppose your channel is a faded channel, much more faded channel, it is weak channel. So your signal transmission cannot give more reliability because the channel is faded channel. Whatever the amount of information signal you can send, the signal strength will decrease rapidly due to this faded nature of channel. So sometimes, even though you are sending your information with good quality amount of power at the transmitter, it may not reach the destination because of this faded channel. Even though it reaches the receiver, suppose it is unable to meet the threshold value of this receiver circuit, it is unable to enter into receiver circuit. Means any signal which is coming to the receiver, if it is not meeting the threshold level of receiver circuit, it will not be identified by the receiver circuit. It will not be allowed into the receiver circuit also. This total journey of information signal getting wasted because it is not maintaining the minimum signal strength, unable to maintain the signal strength due to the faded nature of channel. In these particular cases, what we need to do in real-time environment, we don't know the channel conditions. We don't have channel state information, how that particular channel is, whether it is completely faded or it's a good channel, whether the reliability is good or bad, we don't know. In those cases, this artificial intelligence, ambient intelligence, adding some smartness to the system, dynamically monitor the condition of channel. So it has the capability to dynamically monitor the condition of channel. First, we will send some rabbits like channel estimation techniques. We can predict the nature of channel. With this ambient intelligence, included embedded analysis and decision-making capability of a network. If we add smartness to the network, with the help of this smartness, dynamically we can analyze the behavior of channel. Accordingly, we can prepare our information signal. Let us assume the channel is very weak. It is unable to send our information through this channel. If you send your information, it completely get lost. You know that with the help of monitoring, with the help of ambient intelligence. So what are the alternatives we have? Instead of sending your information through a weakest channel, select one more channel, go for alternative channel and send your information through that alternative channel, which can enhance the performance of the network. So in real-time monitoring case, to know about the channel conditions of a simple communication system will enhance the performance of the system. That we can do with the help of ambient intelligence system. And not only predicting the nature of the channel, accordingly doing some resource allocation, how much power we need to assign and what frequency we need to, how many number of signals getting multiplexed, how we can use the available spectrum, how we can address the energy problem. Spectral efficiency, energy efficiency, these are the two design goals of any communication smart radio network in nowadays. So that means always the spectrum is limited. There is no change in the available spectrum, but day by day the number of users are getting increased. The number of subscribers for any mobile network is getting increased by a factor of million and trillion and billion. But how it is possible to accommodate those many number of users within the limited spectrum is always a design goal. That is called spectral efficiency. Within the limited spectrum, how to accommodate many number of users. The second question is how to accommodate these many number of users with the limited energy constraint. So energy efficiency, spectral efficiency, these are the two design goals every time. So using this ambient intelligence system, what we can able to make. So we have the possibility to monitor our channel every time. Based on the condition of the channel, we can prepare our information signal X. We can prepare this X. So that means we can allocate the resources. We can allocate the number of channels available to us to a particular transmitter, a particular user. At the same time, we can minimize the impact of noise. So these things are possible using this ambient intelligence system for a smart radio environment. Suppose it is between vehicle to vehicle communication, that also possible. Device to device communication, that also possible. There is a only change with respect to the distance of communication, whether it is a long distance communication, short distance communication. So based on the range of communication we have with respect to distance, so the possibility of modeling the channel will have. So suppose take any smart radio environment, what are the steps we need to follow to implement it as an ambient system model? So as we have seen already, we need to analyze the channel first of all. So determine whether it is long range or short range. So depending on the type of or range of communication, now model your channel, modeling of channel. So what's the meaning of modeling of channel? So depending on range of communication, type of channel should be selected. So suppose it is a long distance communication, operating frequency will be different. Short distance communication, operating frequency will be different. In long distance communication, the only impact we have is path loss. If it is a short distance, so the distance of communication is very less, but the signal varying capability is more sensitive. The signals are more sensitive for a short distance. Take an example of a radio communication within a room, a single room, where the distance is very small. Even change in position of a small obstacle will change the performance. Simple opening and closing of a door or window, slightly changing of any either fan on condition or off condition. Small changes in the object orientation also will change the performance. So short distance based signals are more sensitive and signal variations are more. So with respect to those changes, we need to model the channel. If it is a long distance communication, the signal may go under propagation mechanisms. The signal sometimes may go under reflection, diffraction, scattering, because it is a long distance communication. Transmitter and receiver, they don't have line of sight communication. They are not visible to each other because it is a long distance communication. So the signal, it is a free space communication outside medium. Surely it is multi-path propagation. One direct component may be, may not be, but remaining all are indirect components only. Among all these indirect components, they may reach the destination in different formats. So the signal may go under reflection, attenuation, scattering, diffraction. So many propagation impacts are there. But depending on type of environment we have, whether it is urban area, suburban area, metropolitan city, rural area, remote area. Depending on that, we need to model the channel. After modeling the channel, so prepare our resources, resource preparation. So how much amount of bandwidth we have, and with respect to that, how many number of users we have, and how to allocate this available bandwidth to the number of users, and how many number of signals to be multiplexed. So next, preparation of information signal. So it is a constraint about transmitter and receiver. Transmitter and receiver. Next, during the propagation mechanism, how to analyze the performance. It is a performance analysis, and optimization. How to make it more prior, robust transmission technology. If you do all these things for any communication system, but how to do all these 5 steps with the help of ambient intelligence system. So if you include some smartness to the network, so this resource allocation will address properly. We can model our transmitter and receiver properly, such that if you know the first 2, modeling of a channel, whether it is long distance or short distance, if we have information about the channel and all, 3 and 4, we can do betterly with the help of ambient intelligence system. We can improve the performance. So now the system has the capability of self-monitoring. A network has the capability of analyzing the things. Finally, the network itself having the capability of taking some decisions automatically, dynamically to improve the performance. Now the question is how to adapt it adaptively, dynamically every time. So what are the parameters we need to have for this monitoring and all? So signal to noise ratio is the most important factor of any communication system. So if you write signal to noise ratio of a particular simple communication system, it should be like this. So a simple source and a destination. In between, let us assume the channel. If the direct link, let us assume HST. The direct link is not good. We are taking another link. It is indirect link. Let us assume this is through some node. So this is HSD1, another one. So how we can determine whether the channel is good or bad? Now we can determine with the help of this ambient intelligence system. So we need to prepare some data set as simple as keep a threshold for SNR. Keep a threshold for SNR. How we can calculate SNR, signal to noise ratio. So for information signal X, I need to transmit it to the destination. It becomes as Y. It becomes as Y. If you write the expression Y is equal to HSD X, if you apply a power of P plus noise is NST. Let us assume HX plus N. Basic formula, if you write the basic formula we have is Y is equal to HX plus N. Now the channel in between it is HSD. The information you have transmitted is X, and the power we have applied is energy of the signal is under root of power is energy. So under root of power PS is energy and NSD is noise. Now within this, the amount of signal component. The first component is signal component. The second component is noise component. I want signal power. This is SNR is signal to noise ratio. Ratio of signal power to the noise power. So the noise is random in nature. For this, I am taking the variance, noise variance, sigma n square. It is the noise power. And coming to this, the amount of energy I have is under root of PS. So the power is PS. And the square of the channel coefficient, it is gain of the channel, HSD whole square. If the channel is random in nature, in real time, it is a time variant in nature. So if you can take a mean of this channel coefficient, square of the channel coefficient, we can call this is gain of the channel, gain of the channel. If you include these three parameters, it is called signal to noise ratio of the particular link. So using our ambient intelligence system, it is our job to monitor every time what is the amount of SNR we have. So that depending on the amount of power we have applied, amount of noise we have, and the gain of the channel. So that means we need to know what is the amount of HSD. It is called perfect CSI. If you know channel state information, it is easy to estimate the amount of channel we have. If you don't have that information, we need to estimate it. So channel estimation we can do with the help of ambient intelligence system. Ambient intelligence system. And now I know the value of SNR. So I have a possibility to monitor SNR. Now what we can able to do now? So put a threshold for SNR. Put a threshold for SNR. Let us assume 0 to 30 dB is the range for SNR. I'm considering for my communication technology. For my particular communication system, I considered the range is 0 to 30 dB. Within this range, 15 dB is the middle point between this 0 and 30 dB. Let us assume it is the threshold we have. If our SNR, link SNR is less than this threshold, the channel quality is poor. If it is greater than this, the channel condition is good. The channel condition is good. So these are the rules I have made in my smartness of a network using ambient intelligence technology. First, I collected the information from the network. I observed the value of SNR. How much the value of SNR? If the SNR value is less than the threshold, I can understand the channel condition is poor. If it is equal to the threshold, it is average. The quality of the channel is average. If SNR is greater than the threshold, the channel condition is good. Fine. Now first I come to know the nature of the channel. Because I already evaluated, monitored the value of SNR with the help of ambient intelligence system. Within that I analyzed. Now I compare with the data set I have. So by compare my SNR with the threshold value, in the threshold value with the smartness of the network is a part of ambient intelligence system. In embedded system we can store the value of threshold. Whatever the value of SNR we evaluated from the sensors and from information, whatever we have transmitted, know the condition of the channel. According to the condition, act accordingly. So now, a condition I have is poor. What alternative, what action I can take? So I can go for another alternative channel, one possibility, or otherwise, I know the channel is very poor. Assign more power, assign more power, assign more power. So automatically it can overcome the limitation of this poor channel and the reliability of the transmission is good. If the channel condition is good, no need to take any precaution as it is, we can increase the, send the information as it is. Sometimes we have to improve the power. Sometimes we have to reduce the power. Sometimes we have to send the information as it is. So it is the solution we come to determine after analyzing the nature of the channel. So analyzing the nature of channel is one particular kind of thing. And how we can do it? So every time we need to add this smartness to the network itself. Now it is the burden of network every time to monitor, every time to analyze, every time to take some decision over the analysis. But how come to optimize this network? Ambient intelligence system. What are the design goals or what are the problems we have with respect to artificial intelligence or ambient intelligence system? So every time we need to process the information from the monitoring capability sensors, maintenance of these sensors, proper calibration of these sensors, basic signal processing operations, at the same time optimization. If you are not taking proper decision on the analysis, our total performance of ambient intelligence system will go wrong. So it's completely based on how effectively you are taking decision. The decision capability purely based on how effectively you are preparing your data sets. And how effectively you are monitoring, how effectively you are making it as proper information. Each and every step of this ambient intelligence system will determine its performance. So this is the basic behind ambient intelligence system for smart radio. So take any one example. Let us take an example according to the current situation, like a COVID kind of thing. So how we can make a smart healthcare system, using this ambient intelligence system particular point of view. Let us assume a remote case, an ICU kind of unit, a particular patient present inside the ICU, his condition was critical. Remotely, we need to monitor him. Remotely, we need to control the things within the room of this particular ICU. Let us assume here a patient is there, and we can keep some sensors around him. Remotely, we are monitoring his health condition using the sensors. The information collected from sensors will be given to basic signal processing operation. So we can do here signal processing. So after the signal processing, we have data set comparison. We can call it as data analysis. From the analysis, we can take some decision, this decision-making capability, automatic decision-making capability. Whether the patient condition is good, no need to inform to the doctor. Everything is fine. If it is not good, inform to the nearest possibility through an IoT network. So just update the information, whatever the decision or monitoring capability we have. So just update the information in the cloud. So that data will be transmitted to or collected by a proper doctor and team. So they do some rescue operations. So here some decision making capability. So whatever the decision we can take, that will be updated in IoT cloud. So in the cloud using IoT domain, we can update. So this information will be collected by a remote place, actual doctor and team. And they can control this particular patient again through the IoT medium we have, And this will come to the ICU network. We can control some small things within this ICU. So it's a complete closed loop. This is one type of cyber physical system. We are creating a virtual interaction between a virtual thing and a reality thing. We can create communication between a human being and a machine. We can create a communication between a human being and an electronic device. So that is possible here. So a remote healthcare system we can implement with the help of all these things. So how we can perform? What are the design goals we have? Introducing new kind of machine learning algorithms, new kind of artificial intelligence algorithms, which can improve the performance by properly analyzing the data, by properly taking the decision. So most important thing. And coming to the sensor node, their maintenance and their lifetime. So the energy requirement of these sensors. So they are limited energy based devices. So those energy required for the maintenance of sensors, they can harvest from the information itself. So energy harvesting is a new kind of technology where we no need of any external battery services for the maintenance of nodes. The nodes are self-sustainable. They can generate their own energy, the required energy for their maintenance from the information transformation itself. It is an example of Swift technology. We will explain those things also. What is the example we have considered for our analysis? What is the example we have framed as a part of our discussion that we'll discuss in second session of our today's topic. So this sensor lifetime improvement, the sensor node maintenance, their energy requirement, how we can improve these two. Energy maintenance, we can completely make it as self-sustainable by energy harvesting. How to introduce energy harvesting with the smartness will be one real-time challenge. It can improve the performance of ambient intelligence. And you can do some operations in cloud computing. So operate at different layers. So most of them are operating on higher layers. So most of them are operating in physical layer. So depending on the type of layer you have selected, you can improve the performance. So coming to the lifetime of sensor node also, how to improve the lifetime of sensor node, that also you can improve. And coming to the signal processing applications. So your information you collected from sensors, not only sensors, the type of information you collected from a human being or an electronic circuit or a machinery, what kind of information source we have, based on that, the type of information signals are there. It may be one-dimensional signal, it may be two-dimensional signal, it may be three-dimensional signal. Suppose the proper information you have collected is a simple scalar, a vector, a matrix, a simple an image, a voice signal, an audio signal, a video signal, a real-time multimedia signal. Any kind of signal, we need to process it. So the possibility of compressing something, the possibility of expanding something, the possibility of amplifying something, the possibility of reducing the level of noise of something. So all these proper validation of signal processing applications, making it as more prominent form of information, preparation from raw data we have collected from the sensors. This conversion will improve the performance. So most of them, they are operating over images and real-time video signals to improve the performance. Next near future, very soon, we have virtual reality. There is no physical presence of a human being, but we can feel its presence, a particular person's presence, and his emotions we can able to monitor, and we can able to communicate with him, not physically but virtually. How it is possible? If you know the signal processing behind its information, how a person can behave. Every emotion of a human being is a signal. If you properly trace that signal, we have a chance to monitor it clearly. We can analyze its performance. A simple example, without a physical person presence, how we can change a channel in TV, a smart TV, based on the human expressions we have, whether he is happy while watching that particular channel or not, based on his facial expressions, we can automatically change the particular channel of a smart TV. So that is one possibility we have with the ambient intelligence system. How it is possible? If you can properly trace an emotion of a human being, if you compare with the data set available, if you take a proper decision about that, surely it is not a happy moment. He is not happy with the present channel. So there is a need to change the channel. So that we can determine by a ambient intelligence system. So what we can able to do now, if you want to improve the performance, the maintenance of sensors is one research movement or one research direction we have, and doing proper signal processing operations, the second research challenge we have. So you can operate on multi-mode signals, multimedia signals. With respect to the signals and systems or signal processing applications, we can call this as operate on more than two-dimensional signals. Operate on more than two-dimensional signals, sensors. So that is one design goal. And coming to this data analysis, how to prepare real-time data sets. And most of the real-time cases in next generation wireless networks, preparation of data sets will surely help to improve the performance. Nowadays, we don't have proper data sets for many applications. That's why implementing the test beds for next generation wireless networks always not completing within the given bound of time because of non-availability of data sets. And even though we have some data sets, they are not prompt. So what we can able to do? So if you take proper precautions, if you have a chance to store all possibility working conditions of any machine or any electronic devices, what are the all possibilities of working conditions, how it can behave and all. So that will surely help you to take proper decision. So always decision making capability will improve based on the quality data set we have. So preparation of data set always improve the performance. So create a complete, we can say more robust data set based on which we can take proper decision. That also will improve the performance of ambient intelligence system. And coming to the decision making capability, nowadays we have many machine learning algorithms, artificial intelligence based algorithms. So most of them, if you start with the basic thing, how we can start our analysis and all, you just start with an optimization. So just to go to the nature inspired, bio inspired algorithms, like genetic algorithm, particles from optimization, differential evaluation, invasive weed optimization, and coming to that evolutionary algorithms, from evolutionary algorithms, soft computing algorithms, as a part of that, so you can move towards this fuzzy, because in fuzzy only we can take proper decisions. In simple case, making the rule system, how we can analyze the data set, how we can take a decision and all. If you're not completely getting proper decision from fuzzy, you just improve that to neural networks. So train our neural network properly with the data set available and take some decisions and come into so machine learning, whether it is supervised or unsupervised, unlicensed. You can get into any type of this supervised or non-supervised machine learning things. You can solve this decision making capability. You can add artificial intelligence with the help of any one method of this. You can solve this decision making capability problem and include this IoT. Include this IoT. So update the amount of information we have with the nodes, and the node can communicate through a cloud with the users and all. And users will communicate their decision, their controlling operations with the machinery or with the smart transmitter, whatever we have. So there is a possibility of every time. And there are three domains again. there are 3 domains again, how we can address this total system model and all. So that also we will discuss here. So what are the 3 possibilities? Those who want to do in mathematical modeling of this total system model, ambient system model. So first they can do mathematical modeling. Mathematical modeling of this particular system model and do some simulation for the particular environment we have. And the most important, the third one, where many of the researchers are facing this problem nowadays. Every new kind of next generation wireless network, formation of a network is easy. Proposing a system model is easy. If you analyze that system theoretically, we have to face some problems. So mathematical modeling in the sense, evaluate the performance analysis mathematically. Evaluate the performance of any system. Suppose a simple transmission system I have, I can calculate the performance in terms of symbol error rate, channel capacity, throughput, outage probability, intercept probability. So these all are performance metrics. If you evaluate those parameters mathematically, that is nothing but mathematical modeling of a system. Simulate that system model, whatever you have proposed. So just to do the simulation of this and obtain the performance metrics, obtain symbol error rate, result with respect to SNR as a simulation result, obtain channel capacity with respect to SNR, obtain outage probability with respect to SNR, that is simulation results. That is a simulation of a mathematical model. And the final last, real-time implementation. So that means a test bed, implementation of a test bed, converting the simulation codes, whatever we have, into real-time test bed based FPGA conversion, implementation of FPGA or FPGA implementations of our developed algorithms. They are in simulation, they are in mathematical. So real-time implementation of algorithms is simply call it as FPGA design of your algorithms proposed in simulation and mathematical modeling. So this is the most important research challenge we have. So coming to your ambient intelligent system case also, sensing, automatic action, interaction, intelligent interaction, everything is possible. Everything is possible in mathematically and in simulation, except in FPGA design. How to implement these things in a real-time board, a simple FPGA board, how we can implement these things. So surely this third point will enhance our research in considerable amount of way. It makes the difference. You believe that throughout our researchers of India, very less amount of researchers, not more than 20%, they are addressing real-time implementation of communication protocols. We don't have this design. If you include this FPGA design of our communication protocols, that surely will help you. That gives you a real-time picture of any application, whether it may be a smart healthcare, smart radio, smart vehicular, smart intra-terrestrial, smart satellite application, any kind of application, even it is a smart underwater communication. So we need to have some board application, real-time test bed application, that we can get it from FPGA design only. So if we need to operate, we need to complete these 3: mathematical modeling, simulation, and FPGA design. So now these are the possibilities we have. So simulation we can perform easily, and the mathematical modeling also we can do, and try to have FPGA design also. And what are the steps we have, and how we can make as a step-by-step procedure to evaluate an ambient intelligent system. So as a first part, we can propose a system model. The system model may be anything. I'm saying again, the system model may be anything. So the system model may be a smart radio, smart healthcare, smart city, smart agriculture, is simply smart remote, whether it is a short distance communication or large distance communication. Select a system model. One example we will discuss in afternoon session. And for this, do the performance analysis. do the performance analysis. So the performance analysis in terms of performance metric, try to evaluate what is the bit error rate, try to evaluate what is the channel capacity, what is outage probability, whatever maybe. And next, define a problem. Define a problem. The problem may be anything. The problem may be resource allocation problem. How much amount of power I need to allocate, how much amount of bandwidth we need to allocate, or how to allocate the available resources, bandwidth, energy, number of users, which channel we need to assign to which user, and quality of the channels. So everything is a problem. So simple example, I want to maximize the throughput. I want to minimize the error. How it is possible? That is my problem. My problem is I want to improve the data rate of the system. I want to improve the channel capacity of the system. That is my problem. So how to address this particular problem? Solution. It is nothing but addressing a problem is nothing but optimization. This is nothing but smartness. So it is optimization. So we need to solve this problem with the help of optimization. It is, we can call it the smartness of the network. We can able to address this problem with the smartness. Here we will take the help of artificial intelligence. Artificial intelligence. And then it improve the performance. Compare your proposed thing. This is our proposed thing. You defined our own problem and you solved it. Compare with the existing ones. And the last important, much more novel thing. This is the novelty we are including. FPGA design for our algorithms. This is the problem you have defined, you solve it. The solution for a defined problem, it's an algorithm. For this algorithm, if you implement FPGA design, you can convert this total as a test bed. It is a test bed. So introduce this test bed, get the IP, and you have a chance to commercialize it. You can exchange or you can commercialize your product as a test bed to any industry. So these are the steps you need to follow. So you have to frame a simple system model. For that, you need to do performance analysis and you have to define our own problem and you have to optimize it. Solve this particular defined problem with the help of artificial intelligence. That may be machine learning, that may be neural network, that may be fuzzy, that may be evolutionary, that may be bio-inspired algorithms, nature-inspired algorithms. Whatever the kind of optimization you can introduce, or simply it is a convex optimization also, mathematical tools for optimization, that also you can. And compare with the existing techniques we have. Finally implement FPGA-based design for proposed algorithms that surely will enhance the network performance, and there is a chance to implement in real time. We can call this as implementation of test bed. We can commercialize our product, our own product. So this is the real-time product which can solve a particular kind of problem of a smart radio network. I'm proposing it as an ambient intelligence system, and we can propose it. So now we just revise the things whatever we have discussed till now. So we just introduced what is an ambient intelligence system, what the physical meaning of that, and what the basic principle behind this ambient intelligence system we have seen, and what are the operations we do perform under this ambient intelligence system, and what are the possible challenges we have with respect to ambient intelligence system, and what are the operations we do perform. That also we have discussed. And finally, if you want to improve the performance of an ambient system, intelligence system for smart radio network or smart city case, and how to implement those things. We already tested some performance analysis, and we have taken some challenges and some steps what we need to follow. And finally, if you want to implement that as a system model, what are the operations we need to perform, we have seen. And most importantly, as an example of smart city, if you want to include in smart city, a smart parking, a smart radio communication, a smart vehicular communication, a smart traffic avoidance, a smart road accident prone system. Every kind of a smart radio network you can able to monitor and control, and you can take a decision. Remember, these three things should be there in ambient intelligence. So every electronic device circuitry should be monitored properly, should analyze it properly. You have a capability of making decision. You should have a capability of making a decision with respect to this. And when you are operating over a smart radio environment for a cellular network or mobile network, most importantly for a smart city. Nowadays, every metropolitan city like Bangalore and Hyderabad, so more number of obstacles we have in the form of vehicles. The user density is more. So if you take an example of BGS tower, like an example of early morning 7:30 to 9 or 10 BGS tower, evening 4 to 7 or 8 BGS tower. During a BGS tower of a radio transmission, how to analyze the performance, how to get the best performance. Even there is a large amount of human density, population is much more number of subscribers and more number of obstacles, and the obstacles are in mobility. If you consider mobility into picture, Doppler shift is there. So then they become as frequency selective fading channels, not flat fading channels, frequency selective fading channels. How to analyze these frequency selective fading channels in real time? So you want to improve the performance, type of communication, range of communication, type of the channel. Depending on the type of the channels, what are the parameters we need to consider, how to analyze them. So these all factors, first of all, help you to prepare a proper data set, and implement proper machine learning algorithm, select proper artificial intelligence method to solve our data set problems and all. And they take proper decision, and you can control our things. And always our goal is to address any smart radio environment with the help of a test bed. Make it as more specific one. Your test bed should be more specific. Take any one example of IIT or ISC Bangalore, and how they will get request from industry and all. So they have a specific task. So for that particular specific task, they want to implement a test bed. A simple 5G test bed I want to implement to solve it for smart radio environment, which has the capability of ambient intelligence system. I want to find out the reality. So what kind of sensors I need to take? What kind of data sets I have to prepare? What kind of signal processing operations I do perform? And how to implement the algorithms, how to convert into a PCA. So these are all steps behind implementation of any ambient intelligence system for next generation wireless networks. So in afternoon section, what we do, we take one system model. How to do performance of that, how to define a problem for that, how to do optimization for that, how to implement a PCA design for that, and what are the research challenges we have. Still we have to address those who want to continue in this domain, and how they can define their own problem. So these things we will discuss in afternoon session. So thank you all. If you have any doubts, you can ask.
Dear participants, if you have any queries, please.
Sir, Kiran sir, good morning, sir.
Good morning.
Yes, sir. Sir, me readily available test bed is there, sir, for this
Sir?
Any default setup is there for sir?
ISC